Hello, statistics students, and welcome to Chapter 2 examples. Here we're going to be using a chart, a two-way table, and one of the variables here is sports cars, like either you own it or you do not, and then how many accidents you're in, 1, 2, or 3 or more there. And what we want to do is we want to find the marginal distributions, both in counts and in percentages. So we can do the counts first, and this shouldn't be too terrible. And of course, when we're doing this marginal distribution stuff, we are essentially taking each of these two-way tables and we're making it into a one-way table. So if I'm doing accidents here first, I'm taking these two numbers, right? It's basically like I don't care about the sports car aspect. How many people had one accident? Well, 180. Right, and then I would continue, right? I'm adding these, so I get this 280 here. I add these, and I get the 200. Now, there is the marginal distribution of accident count for 1, 2, and 3 or more of this set of data. Now, it does say that we want these as percentages as well. So if I want it as percent, I need the total, right, of the whole thing. Well, if I add all these up, I should have the total of the table, and I think that is 660. To get the percentages, then I'm just taking 180 divided by 660. That comes out to be 27%. And then I am just going down the line and I'm doing the same thing, right? So then this would be a 42%, and this is 30%. Now, of course, my rounding is probably a little bit off here, but in general, these should add up to 100. I think this adds up to 99 just because I have a little bit of rounding error inside one of the 10 spots there. But there's how we find the marginal distribution of accidents. We just did the accidents, okay? Now, if I move over and I do the sports car, right? Now we're going for the sports car. Now I don't care about the accidents, so it's like I'm taking these two, right? These two columns here, or I should say 3 columns, and I am smashing them all down together into one single column. If I do that, I'm taking these numbers here and I'm adding them. Adding those up, I get 450. Then I add these, right? And I get my 210. Of course, if I sum these green numbers, I get this red one. Now this green, right, that means the marginal distribution in count of sports car, only sports car is 450. If we want percentages, again, this is not difficult for us. If I want a percentage, I just divide by 660, and I get the percentage of 68. And then this one down here would be 32%. Okay. So if I'm asked a question like, what percent of people own a sports car? Oh, well, that means I don't care about the accidents at all. I just care about owning a sports car. Well, that is my 68 here. Okay, and so on. We could ask all sorts of questions. In fact, here I have one. What percentage of all people have been in 2 accidents? So when I'm thinking about this, it doesn't matter to me if they own a sports car or not. So I don't care. I just care about if they're in an accident. So I only care about this here, right? Well, that's 280 out of how many? Well, it said percentage, so that must be that 42%. So hopefully that's not too bad. As we move down, we have some other questions that we could do. It says describe all counts in the table as percentages. All right, this means that I'm not breaking it up at all. If it says all counts, right? If it says all like that, what I have to end up doing is I have to create a table. I am going to need to create a new table. Well, if I'm going to do that, I might as well actually create the table, right? So I have own, I have not own, and this is, of course, for a sports car. And then up here, what columns do I have? Well, I have a 1, I have a 2, and I have a 3 or more. right? I'm creating this table here, and I haven't given myself a ton of room, but up here this is accidents. Okay. And what I'm going to do now is I'm just going through and I'm percentaging out all of the individual cells. So I have this 80 in here. I'm taking 80 for this one here. I am taking 80 divided by the total, which is 660. That'll tell me the percent of people that own a sports car and have been in one accident. These are probabilities that have two conditions. You own a sports car and you've been in one accident. So in here, I'm taking, I'll write out the first one in here. That's that 80 divided by 660, which comes out to be 12%. And I'm just doing that through the rest. Now would be a great time to pause the video and just fill in the rest. Okay, now that you've had a chance to fill in the rest, I think I will do the same. Okay, and ideally these would all add up to 100%. Now again, there might be a small rounding error, but I should be close. Okay, I should be very, very close. Then it says, what percentage of people own a sports car and have been in 2 accidents? So I have a couple different conditions that I'm going for here. I need people who own a sports car, so I only care about this row, and have been in 2 accidents. Okay, well, I only care about this column. You can see that these two intersect right here at this 32. So my answer then must be 32%. Of course, I could write that as the count, which from the table that was 210 out of the 660. Okay, but it does say percent, so I need to write that. Okay. Now it says find the conditional distributions of accidents among people who own a sports car given, which that's the given part, okay, versus don't own a sports car. So what we need to do here, though, is we need to split this up, and basically we're splitting it into 2 different conditions, right? It's really kind of one condition. Like, we only care about the people that own a sports car. Okay, so own a sports car, so these people would own one. What percentage of people then would have like 1 accident of those that own a sports car? So when we're doing this now, okay, let me get some of this. Oh, I don't want to do that, but let me get some of this work that I've done up here out of the way here. Okay, so here, as we're looking at this, I don't think I need these numbers. Okay, so what we're looking at now is if I care about people who own a sports car, all of a sudden, really all I care about is this part of the table. Well, how many total people are there in this part of the table? Well, there's 450, right? There's 450 total. Well, what percentage then had 1 accident? Well, that's 80 divided by 450, right? So like our first one, this one would be an 80 divided by 450, which if we divide that out, you get 17.7, which let's just round it to 18%. Now that's 1 accident. What about those that had 2? Well, again, you're going up, and then you're taking the 210 divided by 450, right? And then that's 47%. And 3 would be, well, there's only 36% left in there. Okay, or remember that they should add up. So here we're dividing by the 450. Okay, now we do need like this label 3 or more here. Okay, we need these labels. These are for people that own it. Now we have to do the other side of it, right? So it's like don't own a sports car. Well, same type of math going on here, but for the people that don't, now all of a sudden all I care about is this part of the table, which is dividing by 210. So I'm taking each of the counts and I'm dividing now by 210, which I think you can do that on your own here. That's 48%, 33%, and 19%. Okay. Last couple quick questions here. What percent of people who own a sports car have been into accidents? Okay, so they own a sports car. Right here it says for sure that they own a sports car. And now I care about, oh, okay, so if it's own a sports car, I'm looking here. Let me get a different color. Own a sports car is right here, right? Now it says 2. Oh, okay, then that's this 47%. What percentage of people who have been in 2 accidents own a sports car? Ooh, is this the exact same questions? Well, it turns out that it's not, because here it says who have been in 2 accidents. So this is the given part. 2 accidents. Well, I don't have that over here, right? So I need to go back up to my table here. 2 accidents, that's this column. So I only care about 280, right? So I'm dividing by 280. Well, how many people own a sports car that were inside 2 accidents? Well, that's at 210 here. So it's 210 divided by 280, which comes out to be 75%. Okay, so those are definitely different questions. Okay, much different questions. All right, it's like if you walk through a doorway, if you hit your head, the probability of hitting your head and walking through a doorway. So what we want to do now is we want to draw a segmented bar chart to display the number of accidents for people who own a sports car versus not owning a sports car. And we're going to test to see if there's an association. So what I need to do first then is I need to set up my graph, right? And ideally, right, those should be perfectly straight. Like, I mean, I could cheat, I suppose, since I have the software here to do it. And I can draw perfectly straight lines here. Okay, and then what we're going to do is we're going to come in here and then we're going to create a bar for own a sports car and then a bar for not owning a sports car. Labels are extremely important. Okay. Now it does say a segmented bar chart. So I could do a couple different things here. Typically, we want to do these in frequencies. Okay. So a frequency, right, is a percentage. So I might as well list those out. So let's see here. Like, should I go by tens? 10, 20, 30, 40. Let's write out some of these. 50, 60, 70, 80, 90, 100. Again, you could kind of do it however you'd like. Now, inside here, right, it says own a sports car, not own. So here on the own, I'm thinking about splitting this up as 3 different things, right? So I need a key. Why 3 different things? Well, there's 1 accident, 2 accidents, and 3 or more accidents. So we've done this kind of thing before, actually. Back here, when we created our distributions, basically this red part here, that's red own, is going into the other one. So here I have 18, 47, 36. If I write that down, 18, 47, and 36. Double check here that I remember those numbers real quick correctly. Okay. So I remembered them right. So what we're doing is the first 18, we just go up like 18 here. And I have different colors, so this is where I can kind of cheat here. 18 looks like it's somewhere up like right here. Okay, now because I have different colors and you don't, I will still stick to, okay, this 18 was for 1 accident, so I'm doing like these diagonal lines here. Okay, now that's 18. The next one is 47, but here you got to be careful. It doesn't mean that you go up here to 47, because I need to stack. It's like you're taking a 47 big block and putting it on top of an 18 block already. So I actually have to take 47 plus the 18, gives me 65, and then that is where I draw my line for my next section. And then again, because I have different colors and you don't, in fact, I don't really want to do the lines. Let's do polka dots. Okay, so this red section with the polka dots in here is 47 percentage points big, right? So I put polka dots over here on my key. That's for 2 accidents. Now the rest of it, 36, this should work out, right? It turns out that if I take all of those, that 65 that I had before, and I add 36, it's 101. But that's not a big deal because we're smart and we realize that, oh, it should be like right at 100. Okay, so we draw this here. Again, you can do whatever you want. Maybe I'll do like open circles here. Just make sure that if you don't have different colors that you're distinguishing between the different types. Okay, so there I have that. That's for own. Now would be a great time to pause the video. Okay, next time you come back, I am going to have my not own one drawn as well. So you can see that I have mine drawn. Okay, yours should look something similar. Yours probably looks better than mine. Okay, and we have now our segmented bar chart, right? We have our segmented bar chart. Now the reason we create these is because we can answer this question here: does there appear to be an association? So basically what we're looking at is, do these sections look like they line up? Like this section here, like these lines where they split, do they appear to be pretty close to where these ones split? Okay, such as like this one here and this one here. Do those lines look to be pretty close? And I think, you know, common logic here would tell you, no, those are not close to each other. So if they're not close to each other, basically what that tells us is that it does matter if you own a sports car and how many wrecks you get into. Like those two variables differ. If you own a sports car, your accident rate is different than if you do not own a sports car. So do we think there's an association, if it matters, if you own a sports car or not? Well, we just said it matters if you own a sports car. So our solution here should be yes. The distribution for accidents are different. Okay, and that is what tells us that there's an association. If these bars, these little sections, would have all been split up and lined up evenly, then we would have said no. Okay, now that completes the first example in chapter 2. Check back to the next video for example number 2 from chapter 2.